Very warm good morning to one and all. On behalf of Parul Institute of Pharmacy, Parul University, I welcome you all in today's webinar on the topic HPTLC VisionCATS software training. Before starting, I would like to introduce our today's speaker, Mr. Mohit Upadhyay. He is application chemist at HPTLC Applications Research Lab at Ancrom Enterprises India Private Limited. He has done his MSc in analytical chemistry. He has a work experience of 4 years in teaching with the 11th, 12th G and NET chemistry. He has delivered presentation to various customers in pharma, herbal, cosmetics. He has providing training in troubleshooting with the HPTLC systems, HPTLC application to all their customers as per their requirements. So with this brief introduction, now I invite Mr. Mohit to deliver the talk and enlighten the audience. Over to you, sir.
Thank you so much, Pooja madam, and thank you so much to every one of you. A very good morning to all of you. So today we are going to learn about an HPTLC software VisionCATS 3.1. So now I am going to share my screen and I will tell you from starting how to activate your software for the analysis of HPTLC. So now I am sharing my screen with your permission.
Hello. बोला साहेब. बोला. मजेत चाललंय आनंदी आनंद.
Is my screen visible, madam? Just confirm it so that I can begin.
So your screen is visible.
Yeah. So now you can see this is my VisionCATS software. So double click on VisionCATS software. Sorry for the interruption because there is I'm in lab and there is work going on.
Excuse me, Mohit, sir.
Yes, madam.
Sorry to interrupt you. Sir, actually there is a background noise. So
चालू करते पालन करतोय नाही तर मग परत तो हा 3 दिवसामध्ये झाला पाहिजे दिले मी ओके
Sorry, madam, there is some voice coming from everywhere because we are in lab now. So the work is going on here, but I still I'll try to.
आता आम्ही काय ना ह्याला जाणार आहे
I'll change.
आम्ही जम्मू हा पुणे मध्ये आता 5 लोक बाहेर रमाकांत आरे मारची बेलगावी हा इथे ट्रेनिंग अर्जेंट है ते बाकी के 5 लोगों का तो हो गया ना पक्का जाने का यहाँ उनकी हैदराबाद इंग्लैंड प्लस उस्मानिया यूनिवर्सिटी नेक्स्ट वीक
Hello. Am I audible now, madam? Hello.
Yes, sir, you are audible.
yes, sir, you are audible.
Thank you. So now I am sharing my screen. So double click on VisionCATS software. Once you click on the VisionCATS software, it will ask you for the login ID and password. So now I will log in. I will give my login ID to it first. After giving your login ID and password, click on OK button. Once you click on the OK button, the software will open. So now you can see this is a VisionCATS software 3.1. Version is 3.1. First of all, check the connection of all the instruments. So from where you will check the connection of instrument, just click on here, instruments. Now you can see these are the instrument is connected to the VisionCATS software. So TLC scanner 3 is online. This is not online. AMD is not online. Old ATS is not online. So here from here you can check connection of all the instrument whether it is connected to the software or not. Suppose if your instrument is not showing connection, so what you'll do, you can give the restart your PC and again switch on from the instrument. So it will start showing the connection. Once the instrument and everything is connected, now you'll go for the analysis and method file preparation. So here you can see there are all the folders that we have created for our analysis. 17, 18 is the date and 214 is the project number. As it is 17, 18, 215, all the folders we have created. So our first aim is to create the folder in which we are going to save our method file and analysis file. So I'll tell you. And here you can see M is called as this is called as the folders. Once you click on this folder, all folder will come. Once you click on this M, this is called as the method file where you will create your method for your analysis. So once you click on this M, all the method files which we have created in this VisionCATS software will come in one go. After that, analysis file A will come, and here you can see this is called as the comparison viewer. All the comparison file will come in one go. So now I'll first tell you about how to make your folder and for the analysis. So just click on these three lines. Once you click on this three line, you can see here this new. To click on this new, here it is asking for new folder. Now the new method and new comparison is not enabled. So just click on this new folder. Now give the name of your folder. Normally we will give the name for the our project number, but today I'll just give it its demo software. Demo software, and I'll also give the date also, 15th of March. Once I have created this folder name, demo software 15th of March 2022, I just have to click on this OK button. Just click on this OK. Now just see whether your folder has been added in the software or not. Once you get your not also, you can search your folder. So I'll just write it out, demo software. Here you can see either you can directly search it, or you can search it from here. Demo software, I just click on. So here you can see once you click on this software folder, no, this two method file and comparison file will be opened. So first of all, we have to create our method. So go to this new method. Again, give the name of your method, what you want to give the name. So this method will be considered as your method file. So again, I'll write it as demo, and I'll give on OK. So this demo file is saving in this folder. So this is why we are creating folder. In this folder, you can save n numbers of files. So now I'll just click on this OK. Now, once you click on this OK, the method file has been created. You can see at the top, M is showing method file. Now here you have to give the instrument, which instrument you are going to use for your analysis. So for the work, what we'll do first, this is called as the HPTLC Pro module application. So these are the Pro modules in our lab. Only 2 modules has been come, that application and development. Other modules are yet to be arrived in our lab. So for application, we have 3 applicator, that is called ATS4. This is called as a fully automatic applicator, Dynamite 5, semi-automatic applicator, and manual application. So these are the 3 applicator which we have. After that, for development, we are having ADC2, AMD2, and chamber TTC chambers are there, twin trap chambers are there. After that, for derivation, we have derivatizer, immersion device, and spraying. And for the detection, we have TLC Visualizer 2, Scanner 4, and Scanner 3. Now, first of all, before starting, we will take the clean plate image. Whatever the stationary phase we have selected, normally we, for the R&D purpose, we use TLC Silica Gel 60F254. The batch number is 5554. So we just have to click on this TLC Visualizer 2 for the clean plate image. Once you have taken the clean plate image, and you ensure it whether my plate is completely clear or not. If it is not clear, wipe it with the help of the brush. So I'll just show you. So with the help of the brush, you just have to wipe it at one side, and then take the photographs. Once the photo is done, your clean plate image is done, you can go for the application. So for the application, normally we will use the automatic sampler ATS4, but if ATS4 is busy, we will go for the Dynamite 5. So in these 2 instruments, you can choose. So I am just choosing, suppose, ATS4 for our work. Once you have done the application, you will go for the development. So for the development, we use normally TTC chamber for our R&D work, and the final plate we will do it into the ADC2. So these are the chambers. So once the application is done, your plate is going for the development, where the separation of bands will happen. All the bands which were applied, they are going to be separated depending on their RF. Now the development, after the development, you again go and take your photo. After that, for the development, you will take the photo of your developed plate, how my plate will look like in 254, 366, as well as in white light. and then you go for the scanner. Now scanner is very important and is also considered as the heart of HPTLC. Now why it is called as the heart, why it is considered a heart of HPTLC? Because here you can scan your plate in single wavelength, multiple wavelength, as well as you can take the spectrum. So from there you can get the lambda max of your compound. Okay, what is my lambda max? So at that lambda max you can also scan it. So you can add as many scanner as you want. Here you can see I have added 5 scanner. So as many scanner as in between any step you want to, suppose after that again you have done it and you want to add one more array applicator because your that first application was not done properly, so you can add it. So now I'm just adding only one scanner. I'm deleting all this, so you can delete it also, no issue, until and unless you have not completed that array part. If it is already executed and that work is done, you cannot cancel it. So now you can see I have selected all these 5 instruments for my analysis. Now just click on this finish step definition. Once you click on this finish step definition, this is only in the method file. This is the method I'm going to use for my work. So all the parameter you are supposed to fill it out. Suppose you are going to do the analysis. Suppose what will sometimes what happen, we create a method file, but analysis we will do it on later days. So what you can do, you can save your method file, and again when you come on second day or any day, you can just click on your method file, execute it. Once you execute it, then it will convert it into the analysis file. So it will asking for all the date, and all that audit trial will be recorded from that time. You have started your instrument for photo documentation at 11:45. All this thing will be recorded. It is not recorded in method file, but once it is created to analysis file, it is started documenting everything from start. So what I'll do, I'll just execute this method and I'll just show you. So this same parameter will be executed in the analysis file. So now I am not filling every parameter in method file because I am going to do analysis today itself. So what I'll do, I'll just execute it. Once you can see, once you execute it, it will already give the name of analysis demo as I have given to the method file, and also the date 15th of March 2022 and time 10:42 and 41 seconds. So this is now at this time you have started the analysis of your work. So this is why it is giving all the data. So I'll just click on this OK now. The analysis file, as you can see at the top, analysis file is created. Demo, the name of the file is there, and date and time. At what date and time you have created this analysis. So now I will just cancel this method file because I don't need method file, because now each and everything you have to work on analysis file. You don't have to do anything in method file. Method file will just only save your method, but in analysis file only you are going to do the application. So now all the parameter I'm going to save in the analysis file. Suppose if you have filled every parameter in method file only, I will show you. Now suppose you have filled every parameters in method file only. So once you will execute it now, so in analysis file everything will be executed as it is. All the parameters will be already there. You don't have to fill it again and again. But right now I am just refilling it in analysis file only. Now, first of all, here you can see HPTLC step. First step is HPTLC steps, chromatography second step, data third step, spectrum, SST, and the evaluation tab. This plus sign is called as the evaluation tab. After that you are having remarks, report, and log. That log book, as I have told you. Once you click on log, you can see 15th March 2021 at 10:43. This file created with name demo software, whatever the software, and this is called as your analysis file name demo on this date. So all these things will be recorded as your log. E-signature, report, remarks, spectrum lab. So all these things I will let you know after that. But first of all, we have to start with our. So now you can see all these steps you have selected for your method file. So this same is executed. Finish step definition. So first step again in the same also. You have to select all the instrument which you are using for your analysis. So I have used the clean plate image for. I have used the TLC visualizer 2. Then after that I have gone to application with ATS4. Development with TC chamber, then for clean plate, for the developed plate image again TLC visualizer 2, and after then scanning my plate. Now finish step definition. Once you finish step definition, it is asking for all the parameter to be filled before starting your work of standard and sample. Normally for herbal, what we'll do, we will prepare our standard 1 mg per ml as per USP chapter 203. Standard prepare 1 mg per ml, and for sample, raw sample, you have to prepare it 100 mg per ml. Normally we use the diluent methanol, but if any other diluents are there, that also you have to do it. So 100 mg per ml in methanol. For the extract, you have to take 10 mg per ml. So for standard 1 mg per ml, extract 10 mg per ml, and for raw sample, you have to take the 100 mg per ml of your sample solution. This you have to prepare it in vials, sonicate it, centrifuge it, and whatever the clear supernatant you will get it, that you have to use it for your analysis, because our aim is to ensure it that there is no any particles are there in our vials. Otherwise, our syringe will be choked and there will be not any application will be go on. So for that purpose, we have to ensure it that our solution is absolutely clear for our analysis. Now, I'll first give the HPTLC steps. So I'll just click on this. This is called as a plate layout. The first from first, which is the plate stationary plate you have taken it for your analysis. Now you can see the plate manufacturer is Merck. The plate manufacturer is Merck. Stationary phase, whatever the stationary phase you have selected for your analysis. Suppose I am taking the TLC aluminum plate 60, silica gel 60 F254. So this is very cheaply available, around 7,000. You will get a 25 aluminum sheets of 20 by 20 centimeter, which you can cut down into 10 by 10, 20 by 10. Now in my hand I am having 20 by 10 centimeter of plate. This also you can cut down into 10 by 10 for your use. So now stationary phase. Suppose any new stationary phase or anything other you have selected it, not the plate manufacturer is Merck, so you can edit it. Suppose I am editing here. So once you click on this edit global list, it will ask for the name, which stationary phase you have selected. So here you can give the name key. I have selected this is stationary phase in which the gypsum is the binder. So all these things you can just give the name over here. So now I'll just edit one. See, aluminum plate. Just I am writing this question, TLC aluminum plate, because so many we have edited, so it will not, it will show the same thing again. So once you save this TLC aluminum plate, just save it. This is called as a save button. At the top you can see, once you click on this save button, it will your whatever the changes you have made, it will be saved. Now you can go here, demo file, and you can see whether TLC aluminum plate has come or not. Here you don't have any search option. You have to drag your mouse and see whether you have added it or not. There is no other. If it will be not added, you have to again go and add it, because sometimes the software will take time to. Yeah, so I think it is not added. So what we'll do, we'll again go it. We will save it. Wait. Okay. Edit global list में आओ. Just refresh it with it. It is showing over here. It has been added, but they were not detecting it actually. Because of so many work is going on, so the software is taking a little bit time to. Yeah. No issue. Right now it is not showing it, so I have just added this TLC aluminum plate silica gel 60 F254. But once you will do it, it will automatically be saved, and you can just again see it. Now the stationary phase you have selected TLC aluminum plate silica gel 60 F254. After the plate format, which plate you have taken for analysis. Now in my hand I am having 20 by 10 plate, so I have the plate format is 20 by 10. Suppose you have taken a small plate of 10 by 10, you can select the 10 by 10 plate, or the bigger plate of 20 by 20, so 20 by 20. So normally we will select the, for R&D work we will use the 10 by 10 plate, smaller plate. We will apply standard and sample 2233 bands, and we will see the separation. After that only we go for the quantification. We will use this 20 by 10 plate, where we will apply 15 sample in one plate, and we will see the results. So now suppose I am taking the 20 by 10 plate here. Now application type, always select as band, because in HPTLC we will not do spotting, we will use as the band. Here you will just drag it, you will see all the spot intertrack, band intertrack, area, and other things are there, but these are only be applicable in our ATS4. It is not applicable in other applicators. So now just click on this band for your application. Here you can see this is the plate size you have selected 20 by 10. So that is why it is showing this 20 by 10 plate. Just click on this arrow, application position Y. So from the bottom it will leave 8 mm and apply your plate. So from the bottom it is leaving 8 mm. So application position Y here. Suppose this is my plate. So from bottom it will leave 8 mm and it will apply your band. Now first track position X mm. So from both the side it will leave X mm, that is 20 mm distance, that is 2 centimeter. So here also from 20 mm it will leave and it will apply your first band. So your even though if you are touching your plate from this place, it will not going to affect it, because your band will be applied after 20 mm leaving distance. Then track distance is 11.4. That means the center of one band to the center of another band, that is called as the track distance. That will be kept as 11.4. Application length is also called as band length, which is of 8 mm. Application width will be 0, as we have applied the band. These are the things. Now once if this parameter is fixed, you can apply your 15 tracks. Suppose I don't want to apply 15 tracks. I want to apply only 5 out. I want to apply only 8 or 9 tracks. So what you can do, you can increase this track distance. Now you can see I have increased this track distance. Now you can see I have increased this track distance. So where you will check it whether how many plates are going to be applied. Now you can see only 8 tracks you can do the application. Other tracks we have just deleted it. Okay. So as how many standard and sample you want to apply, accordingly you can increase the track distance. So for 15 samples, suppose 13 samples, so you just have to decrease the track distance 11.4. once you click, by default it will come as 11.4 only, and this is the first track distance is 20 mm in 20 by 10 plate. Suppose I am selecting 10 by 10, it will become as 15. Other parameter will be same, but only it is leaving the 15 mm distance from both the side. So for 20 by 10 it will leave the 20 mm distance, and for 10 by 10 it will leave the 15 mm distance. So now 20 mm distance, track distance will be 11.4, application length. Now solvent front, we will run our plate till 70 mm as per the USP 203 method. तो हमारा जो प्लेट है हमको उसको 70 mm तक रन करना पड़ता है, that is 7 centimeter तक. In case your plate requirement is 60 mm, because in calibration what we will do, we will run our plate in plate till 40 mm only. So that also it is not a hard and fast rule, because it is manually we are changing it. So here you can give the 40 mm. I want to run my plate till 40 mm, because this is completely a for document purpose. They are asking at what distance you have gone for your development. So all these things we are giving it as a documentation. So once you will just generate your report, all these parameter, what are the plates you have selected, what are the X distance, Y distance, track distance, everything will be documented in your results. So that's why we'll first give we will activate our software by putting every parameters in the software, and then only we go for the other work like preparation. And so now I'll just keep it as 70 mm only. Suppose in case you have forgot anything to write, suppose you have selected an TLC plate and you have used the HPTLC plate. So here you can write in notes, I have taken the HPTLC plate. So here you can see HPTLC plate was taken. That you can write it even after the generation of report, and after you have done this process also. This notes is always be open for you. Whatever the thing that you have forgot to write it, that you can write it into the notes. So that also been seen in your report. Stationary phase taken was TLC plate. By default they have selected TLC plate, but actually they have taken the HPTLC plate for their analysis. So that will come in as your report. So notes will only if you forgot anything from this. So now just click on this OK, save it. Now you can see here it is showing star. That means it is not saved. So after every step you have to save your process. Now this step is done. this step is already being clicked as green only, because this is something which we have taken the plate and we have to do the analysis for. Now these are the steps you have to execute it and giving command to the software. Now once I click this continue, then only the software will take the photographs, otherwise it will not. So for this you have to just click on this image. Now image quality, you can see image quality we are having the standard mode and enhanced mode. Normally for clean plate images we will take the images in standard mode only, but standard mode only the photo will be taken, but in enhanced mode they will HDRI option will be on. Now you can see, now I am taking the standard mode. It is for standard mode R white. Normally for aluminum plate what we'll take, we will take our images in R white, R254 and R366. These are the three only wavelength we will take our images in: white light, 254 and 366. But if you are using the glass plate, so what you'll do, you have to use this RTY, that is reflection and transmittance like, and then 254 and 360. These are the four wavelengths you have to select it, because reflectance and transmittance. Here there is no transmittance for this aluminum plate, so that's why we are using only three lamps, three wavelength: R white, R254 and R366. Once you click on this, so all this auto exposure, this you don't have to do anything. Auto exposure level is 85%. 85% it will go and it will take the image of your plate, so that you don't have to do any changes. Now enhanced, once you click on this enhanced button, you can see this HDRI mode is open, that is high dynamic range imaging mode is open. So it will take your image very sharply, and the resolution is also will be good in this enhanced mode. So normally we'll take our photo in standard mode only, because in standard mode it will take image taken will be very faster as compared to the enhanced. Now this also don't have to change anything, repetition 1, internal time. So after each photo the time will be 3 minutes, but we total time estimation around 49 to 50 seconds your photo will be taken for your work. Again, notes if you something you missed it out, so that you can write it. Here there is nothing to be missed, because note is not something. White light you have to take photo, 254 you have to take, 366 you have to take if you are taking the aluminum plate. And for glass plate you just have to remove this and just take this and this, RT and T white, and these two will be common, 254 and 366 you have to take it. So now I am using the aluminum plate, so that's why I have click on this R white. Just click on this OK, and again save your method. Once you save it, this star will be removed. Now first step and second step I have filled it. Now I'll go for the application. For the applicator we are having this sample solvent time. Once you click on this sample solvent type, you are having 5 choices: acetone, ethanol, methanol, water and ethyl acetate, depending on their dosage speed. Now I'll just click on this here. Once you click on this here, it is methanol dosage speed is 150. So from less, that is water having 50, till acetone having 250. These are the dosage speeds. So at this speed they are going to apply your plate on. So this will be going to give the speed. So normally, suppose I have prepared my standard and sample in methanol, 1 mg per ml in methanol and 100 mg per ml in methanol sample. So I'll give the sample solvent type as methanol. So this is the speed it will do the application on your plate. Suppose you have prepared your sample in methanol, and you are going to give the speed to the water or acetone. So that band will be not going to apply that much speed. So that maybe band will be shabby. So for that purpose, in that solvent, if you are preparing. Now the question is, suppose I am not taking any of the 5 diluent for my analysis. So what will do? So suppose you have not taken acetone, ethanol, methanol, water. So at what speed I am going to do my application on? So for that purpose, just do the middle one, because methanol is the 150. From 50 to 250, the methanol is the middle. So always select as the speed of methanol. That is not that it is the diluent which you have used. You can write it over here. The diluent used one by the whatever the diluent is there, but methanol I have selected for the middle speed. And this is pre-dosage volume 200. It is been set filling speed, filling vacuum. This you don't have to touch it anytime. You don't have to touch it rinsing vacuum time. All this thing will be done by the software itself. So this is a fixed parameter. You don't have to change it. You just have to change your sample solvent time. Here also, once you click on here, this filling ranging quality will be standard. Rack type will be standard. you can just click on here, rinsing cycle 1. So after one standard will be applied, it will rinse your cycle. You can increase your rinsing. So I do want, after standard will be applied, I want to give my rinsing 2 times. That you can increase it, but normally we will give 1 time rinsing only. Sufficient it is there. So do not rinse before next one. So if all these things you don't have, actually saying you don't have to take all these things, because it is not that much requirement. Suppose fill only program volume. So whatever the program volume you have filled, keep 4 microliters. So that only it will ask it for. So if you just click on this, that means user, you have selected it. But if you don't do it standardly, it will do your application on your plate. Now the syringe volume, you can see return unused sample into vial. Suppose it will use the you have selected 3.8 microliter for your analysis, but it has taken 4 microliter. So that 0.2 microliter you want it to return to the vial. So what you just have to click on here. That means 3.8 it will apply it, and other 0.2 ml 0.2 microliter which was there in your sample, then it will again return it to your vials. Okay. Now the syringe volume. Now the syringe is having 10 microliter, 25 microliter, 100 microliter. Right now we are using the 25 microliter syringe, so that's why 25 microliter is selected. So you just have to see which micro. Suppose you have in your applicator it is 100 microliter, and you have selected 100 microliter over here, and in your applicator it is 25 microliter. So once you give the command, no, it will not going to start. It will ask it to change your syringe volume. So go here, click on this filling rinsing cycle, click on this syringe volume and change it. Then only it will do the application. Otherwise the software is not going to do the application. For spray gas, as we are having the air compressor, so we are using air, but in your institute and all, many times they use the nitrogen gas for the analysis. So you have to select the nitrogen. So I'll just select this air. Rack type, as I have told you, just have to don't do it while bottom level. So from अभी क्या रहता है कि जैसे हमारा वायल रहता है, तो नॉर्मली वी डोंट टेक कि हमारा सिरिंज एकदम पूरा नीचे से जाके उसको हमारे लिक्विड को लेके आए हमारे सैंपल के लिए. सो फॉर दैट ओनली वी विल कीप इट एट स्टैंडर्ड, कि जितना हमारे पास मिनिमम वैल्यू रहेगा उससे वो लेके आ जाएगा. नोजल हीटिंग एंड ऑल, यू डोंट हैव टू डू एनीथिंग फॉर योर वर्क. अगेन नोट्स में अगर आप कुछ भूल गए हो तो दैट यू कैन फिल इट. सो एक्चुअली मैं सेइंग कि आपको जैसे यहाँ पे क्लिक करना है, सैंपल सॉल्वेंट टाइप मिथेनॉल क्लिक करना है. दिस थिंग यू डोंट हैव टू टच इट, जस्ट क्लिक ऑन दिस ओके. मिथेनॉल एसीटोन जो भी है वो आपको चेक करना है, दैट्स इट, एंड जस्ट क्लिक ऑन दिस ओके. दिस स्टेप इज डन. Standardly it will do the application. You don't have to worry about any work. Until and unless you are not changing, it will not going to do the wrong application results. Now once this application is done, you go for the development. So for development I have selected this TTC chamber. So for this TTC chamber you can just click on. So for TTC 20/10, for this plate you have to take the TTC 20/10. It will require the 20 ml of mobile phase, 10 ml will go for the saturation, and 10 ml will go for the development. For TTC 10/10 it will require the 10 ml of mobile phase, so 5 ml will go for the saturation and 5 ml will go for the development. So 20/20 will require the 35 ml of a mobile phase. So normally I am just taking this TTC 20/10 plate mobile phase. Suppose your mobile phase is already there in your software, so you just have to select it from here, whatever the software, whatever the mobile phase you are going to use for your analysis. Suppose it is not there, so again you can edit it into this edit global list. So you just have to click on this edit global list, fill that mobile phase that I want to use this mobile phase, add the name of it, chloroform methyl ester methanol 751. So that also I will show you how to write it down. Suppose you are writing toluene methyl acetate 7:3. This is how. First of all, write toluene double column ethyl acetate 7:3 bracket में, and after that volume by volume. This is how then it is your mobile phase will be written to the software. As you can write it as you like it, but this is the protocol that you have to follow it. Always write toluene double colon ethyl acetate if it is a mixture of two solvent, and then 7:3 volume by volume. I am mixing my thing. Although just I am showing it, and just save it. That will give you the good. So suppose I have selected so normally for caffeine in green tea or for any other work we will select it. toluene acetone 8 raised to 2. Here you can see toluene thylacete 10 raised to 3, volume by volume is selected. So suppose I have taken this toluene thylacete 1 raised to 1 volume for my application. Now somebody has not written it. So you just have to 1 raised to 1 has to be in bracket and volume by volume is in another bracket. Saturation time will give the 20 minutes for the saturation. And smart alert volume front taper, volume rear taper. Front rough में we will give the 10 ml volume, rear rough 10 ml volume. Drying time will be 5 minutes and here notes and everything. Now photo again. Now you can take your photo in enhanced mode. For your developed enhanced mode, R wide, R254, R366. It will take your image in HDRI mode. Now the scanning part, which is very important, because once you know your plate will be done. Now you have to scan your plate. So now this is the parameter I want to explain it to you. Just click on the scanner. Now scanner type, you can see you are having three options: single wavelength, multiple wavelength, and spectrum. So suppose you know your wavelength is 224, so directly you can select the single wavelength. So you just have to select the single wavelength. Suppose you don't know what is my wavelength, so you know the multiple wavelength, I have to scan it. So just click on this multiple wavelength. So there you can select the multiple wavelength option. And suppose the spectrum. So I'll go one by one. First of all, we are going to talk about the single wavelength. So scanner type will be the single wavelength. Optimization for. So suppose you have taken the wavelength, so always select the light sensitivity. Optimization for light sensitivity, not the resolution. Resolution only select for the spectrum part, not the scanning part. So now we are scanning our plate. So just select the light sensitivity. Measurement mode will be the absorbance. Suppose if you are scanning a plate in 366, then only the fluorescence button will be on. Fluorescence will be on. Otherwise, scan your plate in absorbance mode, like 540 and other UV light. You will use the absorbance mode. So just click on this measurement absorbance. Detector mode will be automatic, you don't have to touch it. Speed resolution slit will be HPTLC, don't touch it. These two things you don't have to touch it. You just have to select scanner type single wavelength. Optimization for light sensitivity. Measurement will be absorbance. If you are taking photo or scanning your plate in 254 and 540 wavelength, only if your fluorescence compound is there, then only select the fluorescence. Scanning speed will be 20 mm per second. Means at this speed it is going to do it will scan your plate. Data resolution after 100 micrometer per step, your data will be seen in your software. So that you have to just keep it as it is, don't change it. Although if you want, you can change it 25 micrometer per step. So it will giving the 20, just after 25 micrometer step it will do the scan. It will directly give you the data. This is how it will look like. So normally we'll select 20 mm per second for the scanning speed, and data resolution will be 100 micrometer per step. This also is as default, it is there, don't change it. Slit size. Now slit size is very important. Now I have taken my band length of 8 mm. So 8 mm 80% will be 6 mm. So 6 into 0.45. 0.45 would be its width, length and width. So 6 into 0.45, by default you have to select it once you are taking the band length of 8 mm. Now the question is, suppose I have taken the band length of 6 mm, then what? Then you have to just take the 80% of it.
As we have seen, we have what as a cluster of all the departments. And if you see in the journey, we have the commerce, we have the architect, we have everywhere. That is the tech expo, but we are not going to do that with the only technology. We are going with all the school of pharmacy, every people are there. So just think about that. How much we are going to make our bond more and more strong, which is going to become the outcome, which is already reflected in all the newspaper and media. So please think about
Hello. Hello. Am I? Hello.
Get the inputs in all the way, and definitely all the student coordinators who rigorously work day and night. Even though a number of times we have met people sir in the because 2 a.m., 3 a.m. in the Dhumkan also with the coordinators. So the people are doing a really wonderful work.
Pooja madam, there is some voice I'm getting.
Yes, sir, I'm sorting out this. Just wait for 2 minutes.
Yeah, madam. Actually, I think they are asking question, but it is quite different topic is going on. Hello, madam, can I go ahead with the software
Yes,
part?
sir, please, you can go ahead.
Yeah. Now, after the slit size you have selected, that is 6 into 0.45. Here you just have to selection will be the user. Here also don't change anything, otherwise your scanning will be not done properly. Lamps, we are having 3 lamps in our scanner. Once you are setting the scanner for, we are having 3 lamps: deuterium, tungsten and mercury. Deuterium is having a wavelength from 190 to 400. It will cover your all the UV part. From tungsten it is having 400 to 900, and all your specific wavelength will become in mercury, like 366, 316. That all wavelength will come in mercury. Just suppose I know my wavelength, that is just select deuterium. I know my plate is having UV, so first of all scan your plate at 254. If you know about its wavelength is 274, then you can scan at 274, no issue. But normally, suppose I don't know what is my lambda max of my compound, so I'll scan my plate at 254 if it is having UV. So suppose my compound is having UV, just select these parameters so that you can take the screenshot also. So select that 254 deuterium lamp. After that, scan your plate at 254. Once you scan your plate, so now I'll directly start one ref file of which we have done it, so that scanning part you will understand it clearly. Spectrum again. Because this file has, they have not taken spectrum, so for that purpose I have just not using that. I'll just take one more file, because other parts are easy to do, but scanning only people are getting issue with, so that only we are going to today work on. Spectrum is familiar, इन्होंने. I am just showing this spectrum part now. Caffeine. Oh. Yes. So now you just have to scan. Now you can see she has also scanned the plate at 254 plus. After that, she will added one spectrum. Now spectrum is added. Now you can see scanner type is spectrum says written. I'll just fill it all the parameter over here in my one. So just go over HPTLC step, add scanner. Again, I'm just adding two scanner. So first you have to scan your plate at 254, and then only the spectrum will be taken. You cannot directly take the spectrum of your plate. You just have to first of all tell to the software key, this is my compound is having UV. Accordingly, it will take the spectrum of your compound. So now, first of all, I have just selected 254 as my compound is having UV. Now just go for the spectrum. So it will draw one pattern. This is how your spectrum will be taken. So scanner type will be spectrum. Just select it as optimization for resolution. Now select. For this wavelength, I have selected light sensitivity. For this spectrum, you have to select the resolution. Measurement mode will be observance. As I am scanning my plate at 254, detector mode automatic, everything will be same. Spectrum speed only it will be showing over here. Slit size again you have to select as 6 into 0.45, as it is the only covering the 80 mm of your band length. Here it is very important. Just change it. Scanner type spectrum, optimization for a resolution, slit size 6 into 0.45. Spectrum per plate you have to give the per track. Only this thing you have to change it. Reference spectrum will be per track. So each track it will going to scan it. It will draw a pattern and you will see the standard and sample. Now our main is you have to just scan your standard and sample and take the spectrum. If the spectrum of standard and sample is matching, that means pattern is matching, that is the indication your standard is present in sample. Suppose sometime what happened, the RF is same, RF is 0.41 for the standard also, for sample also, but once if you are taking the spectrum and the pattern is not matching, suppose the spectrum of standard and sample is not matching, that means you can say though the RF is same of the compound but the spectrum is not matching, that means we can say this compound is not detected in your sample. This is how the detection per track. Also you can take the purity of your standard. So once you click on this purity, no, it will scan your plate, it will do the scanning of your plate 3 times. Why 3 times? Suppose मैं आपको भी बता देता हूँ, suppose यहाँ आपके पास कोई एक बैंड आया है, नाउ उसके उसके ऊपर नीचे भी एक दो बैंड हो सकते हैं, तो उसके नीचे वाले RF पे भी वो स्कैन करता है, मिडल वाले RF पे जो कि मेरा डिजायर्ड बैंड है वहां पे भी स्कैन करेगा, और उसके ऊपर वाले पे भी, उन तीनों को एक साथ वो overlap करेगा, and it will show you कि whether your compound is pure or not. If the correlation coefficient is coming as 0.9, and that means your compound, your standard is pure, you can use it for analysis. Now suppose all the 3 compounds are showing different pattern, they are not overlapping, that means now your standard is degraded, any other compound is also came into that standard, so that you cannot use it for your analysis. So normally we will just identify it, and we don't do purity because purity will take a little bit time, because it is scanning a plate 3 times onto that same wavelength. Now lamp selection is very important. Again here you can see deuterium and tungsten is there. So deuterium is having wavelength from 190 to 400, tungsten from 400 to 900, and suppose you guys want to scan from 190 to 900, so select deuterium and tungsten both. So normally as compound is having UV, so deuterium select karo, wavelength 190 to 400, and just click on OK. These are the only thing that you have to give it in the spectrum. And suppose if you want to scan every from 190 to 900, just select tungsten. And now suppose I want to scan my plate 400 to 900, just click tungsten 400 to 900, just here. And suppose from 190 to 900, to select both the lamp, deuterium and tungsten. So I will select deuterium 190 to 400. Okay, here always remember scanner type will be spectrum, optimization for resolution, measurement mode will be absorbance, detector mode everything don't have to change it, slit side will be 6 into 0.45, spectrum is will be per plate के जगह आपको per track करना है, that is only thing you have to keep in mind. And if suppose if you want to take the purity, just click on over here purity, you don't have to do anything, plate will be already there, will be in the scan your that instrument, you just have to click on this purity, automatically that it will take the purity of your compound, and lamp will be deuterium, tungsten, mercury as you want to select it. Just click on here. Once you will selected this, no, now I will show you this file. Now she has also given everything the same. Now you can just click on data, you will see all the images. Now you can see first she has taken the clean plate image. So the clean plate image look like this, white light 254 image. Now you can see the image is absolutely clean, that means it is ensuring us ki we can do the application on this plate. And also the 360C, there you can see some optical brightness are there, but there is no issue, our company is having UV and my UV is absolutely clear, so I can go for my work. Now as this compound does not have any UV, we are not able to see any bands in the 540, that is white light, we are not able to see any wavelength. But if you just click on this 254 wavelength, now you can see my standard and my sample. So these are the things are there, very important in data. Once the chromatograph HPTLC steps is there, chromatography. Third is data. Here first of all, spot amplifier. Suppose I want to enhance my band, I am unable to see these bands, so just drag your mouse, just select this spot amplifier, just drag it. Now you can see I am able to see other bands also, which bands were not visible at the top in normal UV, that also I am able to see it. So these bands were not that much visible over here, but once you spot amplify it, it will be visible to you. So with the help of your mouse, you can see it. Now you can see I am able to see my standard and sample. Now labels are there. After the spot amplifier, go on this label. Just click on this label. Standard. Now till track number 7, I am having standard. After that, I have applied my sample from track number 8. But now you can see both the standard and sample are coming at the same RF. Here are the RF tips. Just click on this RF tip and just 0.18 RF is for the sample also, 0.18 RF is for the standard also. Now RF tools are there. Just click on this RF tool. So RF tool will be automatic will be shown here. Now I don't want RF. So just click on this RF here. You just have to click on, right click your mouse and just wait. Yes, right click and delete it. I don't want it. I don't want RF. You can delete it. After that, suppose application volume. I want to see at first track how much volume I have applied it. Just click on this application volume and track number. So these are the track number till track number 13 are there. 1, 2, 3, 4, 5, 6, 7 volumes has been applied like this way. And these are the tracks. So all this, so this is come in one go. So now I don't want anything. So I'll just delete everything. That you can just, you have to untick everything and you will see all. These are the only important things. Spot amplifier. Suppose your bands are not visual, so that you can spot amplify it. And others are RF tool or RFD. You want to export your image, so just export image, export everything. To export everything, you select it. So automatically your image will be saved in desktop, like file name develop image. This will be saved. So suppose I want to send someone my images only. Now I'll just show you spectrum. Now I have just, although my standard and samples are there, you can see track number 1 to 7 my standards are there. They are coming at the same RF of 0.18. Sample are also coming at 0.18, but I want to double ensure it whether my same standard is present in sample. So for that I'll do the scanning. So here you can see track, she has scanned the plate track number 2 only, track number 9, 10, 11, 12, 13. She has taken the spectrum off. So Sneha has done this. So she has taken one standard spectrum. So you can only do one scanning. You can delete it also. Okay, I don't want this. Although this step is executed, so that's why I'm unable to delete it. So all this plate will be assigned together. But I want only this track number 2 and track number 10 scan as spectrum. So that track number 2 and track number 10 only it will do the spectrum. Now just click on this spectrum data. Once you click on the spectrum data, you can see this. My compounds is exactly overlapping it. That is track number 2 is my standard. I will open one standard and one sample track. So what I'll do, I'll just click on this subject caffeine. I will on this track number 2 and track number 9, and others I am going to off it. So you can just click on this I and it will be already off. Now you can see both the standard and sample is exactly overlapping. Once this will be confirmed, just click on this maximum. Once you click on this maximum, display maximum. Now you can see the lambda max is 273, 274. That means 274 is my lambda max. Here you will get it. My lambda max will be 274. My compound is getting more absorbed at this wavelength. So after that, you have to go here, add this wavelength, and now you have to scan your plate at 274. Now which we have to, here single wavelength 254, which we are doing now. Now just click on this deuterium and select 274, because now I know my lambda max of my compound is 274 for my work. So this is how we have to do that. We just have to keep your plate, and these are the parameters which I have told you. Just now you have to select it. Now the question is, can you show how to scan it? So now just click. Now suppose 6.1 evolution she has done it. She has already done that. Now I'm just tell you how to do the. So within 5 to 10 minutes, we are going to end this session now. Here, just click on the 6.2 evolution. Once the plate is done, you can do 5 evolution tab. So now see 6.1, she has done it. Now I can again evaluate the things by just changing some parameters. So now, suppose name is caffeine. You just have to write the name. Just click on this 6.2 evolution tab. Caffeine will be on. Now the caffeine is not going to harm because the same name is taking. So I'll just give some other name. Now I've just write caffeine dot. Now you can see calibration type will be the area, because we are taking area, and for fluorescence we will take the height. Calibration mode will be linear 2. For our herbal compound we'll use the linear 2 only. Here you just have to give the how you have prepared your standard and sample. That much only. For quantification, always remember earlier software asking you to calculate it on plate concentration and that put into the software, but this software will automatically calculate your on plate concentration, but you have to provide ki how, what is your standard and sample concentration that you have prepared it. So normally I prepared my standard as 1 mg per ml to 1 mg per ml. You just have to write it over here. Sample also, how you have prepared it? I have prepared it 100 mg per 1 ml of P sample, 1 ml. Suppose related to it is all about कि suppose आपने कोई API लिया and you want to check the label claim कि 200 mg cefixime है या नहीं हमारे पास, so that you have to write it over here कि I have prepared my sample as 100 mg per ml but I am checking the label claim over here 200 mg, so that it will relate to 200 mg of your label claim. For right now I am not doing, as we are only working on herbal, so 100 mg per ml and reference 1 mg per ml. This is the definition step. Then go to the integration. Now she has taken the 254, so just click on this 254. She has not scanned the plate at 274, so just click on the highest of the value. Now this is the track you have to, this is your caffeine. So these are things that you are seeing it, that you have to integrate it. Just click on here and integrate it. This arrow you just have to shift it. Here you can see. Now this is my band. So I just want to ensure it whether my standard is present in all sample or not. So this standard is there. Now sample में देखो sample में भी आ रहा है ये सारे के सारे track which I have selected it. This is you have integrated it. Once you click on this easy mode, no, here manual is there. Just click on this easy mode. You can see the area. Area is 2107 for the track number 13, that is sample. Now you want to show it कि whether it is coming in standard also or not. Standard area is 2047 and sample is 175. मतलब almost है जो standard highest area is 2000 area is there and sample area is around 2100 highest is there. So that also, suppose some of the tracks are not sitting into the range, so that also you can off it. I don't want this track number 4, so you can off it. Now go to this third one, just integrate it and just go easy mode and manual करोगे तो आपको area मिलता है. Area it is this much, maximum RF is this much. Now suppose your standard area is 400 and your sample area is 800. They are not going to sitting into the calibration range. So for that you have to dilute your sample 2:10 or 1/2 करोगे आपको तो वो 800 से 400 आ जाएगा. And then you have to get the calibration. Substance assignment, you have to assign your substance. So just click on this substance assignment, just take this arrow to this substance you want to assign it. So this is the only band I have integrated it, so you just have to assign that only. Just open this arrow and just click on this I button. Once you click on this I button, this green signal will be shown. That means these are the tracks are going for the calibration. So I have not off any of the track as of now, but I see the calibration and then I decided which track is going out. Now you can see the linear to CV is going very high 6.30. Now you can see this track number 4, track number 1. These two tracks are not sitting into the range. So what I'll do, I'll just delete it, or you can delete this also, track number 7. So what I'll do, I'll delete track number 7 and track number 1. I don't want it. So it will ask it whether you want to delete this. Yes, I want to delete this. Substance assignment, again go and again you have to assign the substance, because now you have just treated track number 1 and track number 7, so that's why it is not showing over here. Open this arrow, just click on here, calibration जाओगे, so here you can see the CV is decreased because all the standard which were not there in the range that you have deleted it. Now you can see the CV is 3.12, but here the regression modes are 5. Linear 1 which is passing through the origin. Linear 2 will only going to cover the maximum point from the your standard and sample. So already we will give the report in linear 2 only. Polynomial, it will cover your all the bands, all the track, it will cover it, all the points, it will try to cover it. So now you can see CV is also 1.7. So in most of the cases we will send the report in polynomial also. And this Michaelis maintenance 1 and Michaelis maintenance 2. Michaelis maintenance 1 is the formation by linear 1 and polynomial. So now you can see linear 1 and polynomial. And Michaelis maintenance 2 will be the linear 2 plus polynomial. So now just click on this linear 2 and just click on this result. Once you click on this result, automatically this result is showing that is 615.7 microgram is present in 100 mg of your sample, because 100 mg you have given the sample, and accordingly on pad concentration it will change it and it will give you the result in microgram. Now this is our result. Just click on this report generation. Once you click on this report generation, already your report will be now. Just click on this report generation. Your report will be generated in PDF form. It is taking a little bit time to, because I am just sitting on server only, so maybe server is not able to. Wait, I think the VisionCATS is closed now. Wait, I'll have to again on it. Sorry, as it is. Just generate your report. So just click on this report. Okay. Your report will be generating in PDF form. So writing report data, generating PDF report. So I've opened a completely different file, which I was not using it. So now you can see this analysis caffeine in green tea was done, created by, modified by last HPTLC log. It was showing around 23 December. So these are the track assignments. She has first taken the standard till track number 7. After the sample take track number 13. You have to give the type also, standard and sample. Steps you have selected: chromatography, plates, application, development chamber, toluene acetonate raised to 2, scanning wavelength, single wavelength 254. First she scan it, then she must have taken this. Now you can see the images also will come in your report. This is all the scanning, each track is scanning wavelength data. First she has scanned all the scanning, then she has taken the spectrum. Now you can see the spectrum of caffeine and green tea. After that, she has scanned our plate at 275 wavelength, because this is my lambda max of my caffeine. So that's why she has scanned it. So now you can see each data, and she has evaluated my result in 275 only. Now you can see integrated peak, which she has integrated it after the work. Now you can see the calibration called linear 2. It is sitting a very good CV range of 1.6 is achieved, because that plate is developed it very well. Correlation coefficient is also going to be 0.99, which is accepted, and result is 1.484 mg in 100 mg of a tablet. This is the evaluation number 1. This was done. Evaluation number 2 is also there. Now I don't want evaluation number 2. So what you go, just go on setting. Here you will get all the results which you don't want. Just untick it. Suppose I have untick this. I have untick this. I have untick this. So this will not come in a result. Only the, now you can see no image will become here because I have unticked all the images here. You can see, that's it. No calibration, nothing will come because I have just want the scanning data but not the evaluation data. Here evaluation option also you can go. Evaluation 1, I don't want it. You just untick it because many time we will do all the work in for our analysis, but we don't send all the report to the analysis because maybe a customer want only identification. We do it quantification for our purpose, but we don't send quantification as. So what we'll do, we just delete it. We'll just untake it and only the identification part will be sent it to the customers. Evaluation will delete it. So only he will get the identification of your plate. So why I just want to give only images. I will cancel everything. Untick and just you can see now I have just only click on the images. Only of 254. Sorry, spectrum ho gaya hai. Images. Yes. Just click this here, 254 images. Now you can see 254 image will become 254 and 360. Only images. That's it. This is the identification. And now you can send this report, export it, and you can share it with anyone. Save it, and this report will be saved in PDF form. So this is all about your work. And in remarks also, if you want to give any kind of remark, that you can give it. Suppose this test will be done, so this is Word file will be open over here. Now I'll just show it to you quickly. Now you can see here the test result is okay. Suppose you have written okay, so just click on this save and just again generate the report. At the end of the report you will see the remark. You can see remark I have given is okay. That means it is done. So that is how it is. Just click on this log. So whatever the changes that I have made it, that also it will be. Now you can see it was 15th March 2022, 11:36. I have made some changes. Analysis modified. So whatever the analysis that will be modified it. Now also report also, if you are changing it again and again, report will be this ID. You can see no WNU2 again and again. If you are making changes and again generating the report, your ID will be changing. That means you can suppose you have sent one report and after that again report. So she know about key you have changed something in the report and then you are changing it. So all this audit log will be come in your data. So that is all about the VisionCATS software for your work. For your quantification work, that much is only required. And then as far as you will get to know about other parameters also. But this is how we'll do the VisionCATS software training is done from my side. Now if you have any question, you can ask me. Now the session is open for discussion. So now,
Thank you, sir, for such a wonderful information. Actually, one of our students, those are watching from the Facebook, they have the one question that, sir, as you have gone through the particular example in which you have analyzed the caffeine in green tea.
right.
So that is only one standard, right? But
Yes.
suppose that if we have two components in the sample, okay. Along with the caffeine, if we have some another thing in the one sample, then how we can calculate the resolution between these two? That we want to know from the software point of view.
Okay, suppose madam you are having two standard and one sample, right? So you are having a 15 you are having a plate size of 15 track you can apply. So what you can do, we are only going to work on the 5-point calibration. So 5-point you can 5-point standard you can apply for one standard, 5-point for other, and other 5 track you can apply for your sample. So if you are taking for your first standard evaluation, so you can off your 5 other tracks for standard number 2, which I have showed you. You can off your other tracks. Suppose from track number 6 to track number 10, this is my standard number 2 that I don't want it. So you can off it, and you can only on your standard number 1 to 5 for your first standard and your sample. So it will draw one calibration. Again, go to the evaluation number 2 option, plus like 6.1 and 6.2 it will on. So again, what you will do, you can off your 1 to 5 and on your 6 to 10 evaluation for your standard number 2. So it will draw for the other evaluation type. So this is how you can do the simultaneously both of them in one result only. And once you'll just generate a report, so 6.1 evaluation is also come and 6.2 is also come. That means standard 1 evaluation and also standard 2 is also come. This much amount of standard is present in your sample number 1, standard number 1 and standard number 2. This is how you can do it.
Okay, sir. I think all the queries has been solved in the session itself. So we just like to end up with this. So thank you very much, sir, for providing such a important information on the VisionCAT software. It will be helpful for our master students to do their project work in the next academic year. So on behalf of Parul Institute of Pharmacy, Parul University, I thank PU webinar team for their support. I thank management of Parul University for providing us the platform for conducting the webinar event. Now I would like to thank Dean and Principal of Parul Institute of Pharmacy, Parul University, Dr. Abhay Dharamsi sir, for support and encouragement for arranging this kind of expert talks. I would also like to thank Dr. Falguni Kandel Madam, Head of PQA Department, for her continuous support and encouragement for arranging this kind of the event and all the other webinar and guest lectures. I also like to thank all members of PQA department and other faculty staff for their support. So last but not the least, I would like to thank all the teachers and audience for attending this and making it very successful. Thank you so much, all of you.
Thank you so much. Thank you. Thank you, everyone. Thank you, Parul University, each member. Thank you so much for your support. Thank you. Madam, can we end this session now?
Yes, sir. Yes.
Yeah, thank you. Bye, everyone. Bye.
Bye, sir.